So this was kind of situation of the issue. Let's try to understand European climate policy. It's interesting because it's a forerunner, and you can say it has some kind of economic logic. Has been designed carefully. There is a kind of cost-benefit analysis almost for every step that is taken. I do not necessarily agree with all the cost-benefit analysis, but there is a certain assessment of this policy. Okay. Why do we have an EU policy? EU policy can work because we can impose sanctions on the member states. Once you have signed the agreement in Europe with all the member states, and actually what we need is a qualified majority. So we do not need all the member states. Qualified majority is sufficient. Once the EU has taken this decision to decrease emissions to net zero in 2050, everybody has to follow, and that makes it different from international agreement. Okay. Now, so we are rather ambitious. I think we in Europe, Europe goes to net zero in 2050. Is net zero. It means that they still accept that there can be some emissions of carbon dioxide, but they need to be compensated by absorption of emissions. Now, Europe is to some extent a forerunner. It's possible to be a forerunner, but we have to be careful. If you run too far in advance, you will need trade sanctions, and that's what has been discussed now. And imposing trade sanctions on the rest of the world is difficult for two reasons. The first reason is just a matter of measurement, how to measure what is the carbon content of products that you will import. So these are comparison between the non-OECD and OECD. And usually, if you just count electricity input in a product, it's still relatively easy to know what is the average CO2 or carbon content of the electricity. But that's not the end of the story. You have a lot of indirect effects because you have this input-output matrix. And in the input-output matrix, in the end, you come up with a lot of indirect emissions. And then the question is, for the direct emissions, you can still try to correct, but for the indirect emissions, it's becoming much more difficult. So this is an illustration for very carbon-intensive products. A second reason why it is difficult is that if we want to punish another country, usually, of course, the other country will be, if it has to pay an extra import duty or import duty to the US, to EU, it will be bad for the terms of trade. But we, in Europe, we also pay part of the cost. And that's something that is often forgotten, that if you want to punish another country, it's also costly for the country that is punishing. This is in general the case. Okay, EU is ambitious. This is just one scenario where you see the contribution of different sectors, where the most successful has been the reduction of emissions in the power sector. Industry is following very well. The transport still has to make a large decrease over here. And then you have many other sectors where there still is a lot of work to be done. Okay. European climate policy is actually, you have three components. The most important component is the tradable permits for industry, power, and intra-EU air transport. So why was it used? Because we needed in order to have an EU electricity market. We had France was actually at zero emissions thanks to its nuclear energy. Germany had a lot of coal power. So in order to, if we just would start and say, okay, all these German products, they have very dirty electricity. The German products would never be able to compete. The idea was to have an EU electricity market so that Germany could also buy the French electricity. So everybody could buy electricity that is carbon-free, or whatever the discussion is, less carbon intensive. So that was the idea. They also started with distributing free permits, because industry would have been lobbying very much against any policy where they would have to pay a carbon tax at the start. So they got some free permits, and free permits to some extent a nice present for industry. Second component is efficiency norms for appliances and cars. Why is it necessary? Because in order to keep an EU internal market, imagine again a discussion between France and Germany. France could say, yeah, we are very strong in small cars. Imagine 15 years ago, okay, we only allow cars with a maximum consumption of 6 liters per 100 kilometers, then all the Mercedes, everything which is Mercedes, BMW, would be ruled out, could not compete on the French market. So it's really, the internal market was an important element to use these efficiency norms and to set these norms at the European level and not at the national level. Building and transport was left to the member states, because there's a lot of issues that are local. Let's say heating a house in France is something else than heating a house in Sweden. Okay, whatever. So this graph tells you some kind of, this is the most important graph in terms of European policy. What you see, these are EU emissions in industry, electricity production, and intra-EU air transportation. We have a gap that goes down and keeps going down. Every year we we put at the disposal of these sectors less and less emissions, up to practically zero emissions in 2050. This means that, okay, you can buy emission permits here, you can use them later, so there's some kind of consistency over time, some kind of efficiency over time. And in principle, it's the same price for everybody. So if the price of carbon is the same for everybody, according to simple economics, we know that the emission reduction is located in the sector, in the activity with the lowest cost. This is a little bit less the case for the other sectors. Here we have actually, we still have 27 member states over here. They each have a part of these emissions. They all have to go to zero. But the system is much less clear because they leave it to a large extent to the member states. What can happen is that part, whenever you electrify heating, whenever you start to use an electric car, what you actually do is move from this system into this system. Take an electric car. An electric car is produced by, if it's produced fully in Europe, then it's produced by industry. And it's powered by electricity production. So what you do is you have part of the transport sector that moves from this division to this division. Okay. Something that is often forgotten. So economists tend to focus very much on prices, regulations, is the role of technology policy. If you want to be very ambitious, then you need much better technologies. And for better technologies, you need three elements. First of all, if you develop a technology as an inventor, you have to be sure that whenever your invention is ready, this means in 5, 10, or 15 years, you should be able to sell it at a good price. And because the invention is really a reduction, the benefit of the invention is a reduction of emissions, you need high long-term carbon prices. Can be under the form of permits, federal form of taxes, but you need a commitment that the prices of carbon dioxide will be high. Second element is, of course, subsidies for pure R&D. The third element you need is subsidies for learning by doing. Now, what we tend to have in the EU, the member state, is high long-term carbon taxes, thanks to this ETS, thanks to this cap that decreases over time. But politicians prefer to give installation subsidies. We in Belgium used to have massive subsidies for photovoltaics. And of course, that's much more popular. And we give too many installation subsidies and not enough investments in R&D. Now, the tradable emission permits, they work. But I've had the opportunity to discuss climate policy for 2 or 3 years with many colleagues of my university, engineering colleagues, all very smart. But whenever it comes to very simple things like adding a new nuclear power station in Belgium, you can say, yeah, it will not decrease EU emissions. It's something that took sometimes many discussions to convince people that this is true. Of course, if you add a new if you compare a nuclear power station and a gas station, and you look at the exhaust of a nuclear power station, there will be much less CO2 emissions than for equivalent power in a gas station. But that's not the end of it. You have to run through a whole system of permits, and given that there is a cap and there is a positive price for permits, it will end up to an equilibrium where, in the end, a new nuclear power station in Belgium will not decrease EU emissions. This was very hard to sell to some of my engineering colleagues, and also hard to sell still to some politicians. So we still have discussions about nuclear energy in Belgium, maybe in France too, where people continue to say, yes, we need it for to solve the climate issue in Belgium, and then you have to say, yeah, it's the climate issue, exactly, we do it at the European level, etc., etc. There's a whole debate which is, let's say, it's a popular debate, but it's difficult to explain to the general public. Okay. Another one is that when you hand out free permits, it still raises the price of the product and gives an incentive to reduce emissions in production. It's again very difficult to explain to most people. There's an electricity market that is very important, it's crucial. We need a lot of flexibility. We need to develop much more flexibility instruments. Interconnection is also important. We tend to think about electricity, our electricity production, but Belgium became an import country, and even France, I think for the moment, is importing a lot of electricity. They used to export a lot of electricity in the past. Now they're really importing a lot of electricity. Energy-intensive industry is again a very there are some sectors where it is very difficult. So this cap, this ETS permit pricing is very important, but you need a lot of process innovation in carbon-intensive sectors like steel, chemical industry, building materials. And these new technologies usually need combination of hydrogen. For instance, in the chemical industry, you need to, again, have this. You need to reconstruct molecules using hydrogen and carbon. And both of them are costly. Hydrogen, you can get it in different forms. But if you really want clean hydrogen, green hydrogen, it can be expensive, and carbon is something you have to get out of the air, or you have to capture it at the power station using fossil fuel. I think we need to accept maybe in Europe that we cannot protect all the local production. We, for instance, in Belgium, we say Antwerp is the most important cluster of chemical industry next to Houston, and say we should keep it, but I'm not so sure, because if we want to have a carbon-free chemical industry in Antwerp, we need a lot of hydrogen, and maybe the cheap hydrogen is more like coming from the Middle East or somewhere else, and maybe we need to locate this industry in the Middle East rather than here. Okay. Buildings, there's a lot of also, I think, misconception about buildings. People tend to really focus on density. They say, okay, we need much more density in urban areas. I'm not convinced, because if you look at the technology you need to have carbon-free urban areas, you need things like heat pumps, heat networks, and probably also need green areas for cooling in the cities. So it does not mean necessarily much higher density. Of course, there is a need for spatial coordination. It would be silly to have a heat network where only one house out of two would connect. Okay, for non-urban areas, I think solutions are clear: heat pump, photovoltaics. Main problem there is that we are going very, very slowly. Renewal of the building stock is typically 1% per year. Renovation, good renovation could be less than 1% per year. Let me see how much time I have left. Okay, I need another 5 minutes to go through the passenger transport sector. Of course, fossil cars are an important source of CO2 emissions. I think everybody is convinced of that. And replacement by electric cars reduces emissions when the cars are produced in the EU. Okay, why? Because we have a cap on power production and a cap on any industrial production. What people don't understand most of the time is that we have already high excise taxes. This is typical for Europe, not for the US. We have high fossil fuel taxes. And if you try to see how high they are at the level of 200 euro or 300 euro per ton of CO2. So we have already very high CO2 taxes in the transport sector. Something that is not very well understood. Okay, I know it's complicated, but anyway, it's proportional to the amount of fossil energy you use. So you can consider it as a carbon tax. Strategy is effective, but I think it's costly. I think last week or this weekend, there was a discussion at European level to allow, the Germans pushed to allow e-fuel. So fuel actually based on hydrogen and carbon. Some kind of synthesized fuel. It could be carbon-free, okay. But it's not very effective because probably it will also not pay any excise taxes. So this means it will be strongly subsidized. And you say, okay, it's an exception. Maybe if you drive a Porsche and you will continue, you like to continue to drive a Porsche, yeah, you should either emigrate maybe to the US or pay e-fuel, subsidized e-fuel in Europe. Okay. Now, most of you are very well aware about there's problems of car use, but it has to do with congestion rather than with the type of engine that is used. A lot of people in the past were saying, okay, just make sure that you use electric rail, then there's no issue. Of course, yeah, no, if electric cars are around, then we no longer need rail to solve the CO2 emissions of cars. Okay. This is the relative carbon tax for different types of fuels in Belgium. Okay. Something that cannot be forgotten is some kind of the spillover effects of regulations and of technology. Europe has always applied to the same regulations. If these regulations go to 0 in 2050, go to 0 in 2035 for new cars, they will also be forced to follow the same movement. Freight transport, we should not spend too much attention. The idea is to put everything on inland waterways and rail. I think it's something that maybe worked in Soviet Union. It doesn't work here in countries where you need fast transport, reliable transport. It's usually still transport by trucks. And the main question is whether the electric trucks should use big batteries or use electric motorways. Hydrogen truck is probably has lost the competition. To my surprise, I always thought that trucks would make more sense to have a fast electrification of trucks rather than cars, because for trucks are driven 100,000 kilometers per year or more, while a car is driven 50,000 kilometers per year or less. So if you do the economics, it could be that it's better to start with trucks rather than cars. Electric motorways. One of the issues with electric motorways is coordination between countries. It's not very useful to have a truck that can drive in Germany, can drive in Belgium on an electric motorway, and if you move to another country, and certainly Belgium is a very small country, it doesn't make a lot of sense that we install this technology if we cannot use it abroad. Let me stop or conclude with long-distance passenger transportation. Within the EU, we have competition between high-speed rail and air transportation. Both are part of the ETS cap, so I would say in terms of CO2, there's fair competition. This system works for aviation. There are empirical exercises that have demonstrated that it works. It's much more difficult between continents. We have there the CORSIA agreement that tells us that if two countries join the CORSIA agreement, they agree to cap emissions at the level of 2019. I'm looking at this question. I think it's unlikely to work well. But there's an elephant in the room. What is the elephant in the room? Here, the idea is to compensate emissions of the transport sector, of the long flights, emissions above the level of 2019 by extra efforts, offsets, called offsets in other sectors. But this is not fair. This is not correct, because people have demonstrated, people have found out that emission of 1 ton CO2 at higher altitude will probably generate 3 times more greenhouse gases than a ton emitted in other sectors. So if you say my 1 ton CO2 of coming out of kerosene use at higher altitude, I'm gonna compensate it by 1 ton less emissions in let's say industry or power generation, is not the correct comparison. You should use actually, you should pay for 3 times more. Let's say every ton of kerosene that you emit in the air transportation sector should be compensated by an effort of 3 tons in the other sectors. Okay, it's a complicated story because there are many different greenhouse gases involved. complex phenomenon. If you're interested, have a look at this atmospheric environment paper. If you're interested in this, in the different greenhouse gases. Okay. There's a lot of window dressing by the air transport sector. They say, we are green, but very often, what does it mean, a green? We have a green airport in Brussels, but a green airport means that they can use 2 to 5% of green fuels. So all the rest is still emitting CO2, so it's green, yeah, for 2%. Synthetic fuels remain very expensive, maybe 10 times more than kerosene, so it's very hard to solve. And I think we will need very strong reduction of a very strong improvement in fuel efficiency of aviation.